Welcome to Unpacked, the podcast that examines how technology is reshaping business and our world, with this season unpacking the topic of generative AI. My name's Stuart Black, and I'm joined by the voice of the show, Think Tank's innovation lead, Arvind Ravishankar. Arvind, are you well today?
Hey Stuart, amazing. Looking forward to our show. Full of energy today, full of energy.
In a few moments, we'll have Arvind's deep dive interview with Professor Mausam from IIT Delhi. So Arvind, could you just introduce this one a little bit for us so we know what to expect?
Absolutely. Stuart, I'm excited about this episode and this guest for two reasons. One is he's a leading authority in the world of AI in India, teaching at IIT Delhi and runs their entire research institute. But also, Wipro is funding his research, and we are investing in a lot of the research in partnership with him because we recognized his leadership in this field. And the type of research he's doing is amazing. So I'm looking forward to unpacking some of the work he's doing today and, showing business leaders the evolution of artificial intelligence.
Sounds great. But before that, let's take a look at a couple of AI stories hitting the press recently. Our first story is a fun one. It's all about an unexpected quirk in some AI-powered chatbots where researchers noticed their mathematical ability improved when told to communicate in the style of a Star Trek captain. This was discovered by accident when a Californian software firm called VMware asked various AI models to modify prompts for maths questions initially written by humans. One model suggested tackling the maths problem like the captain of a starship, and this turned out to be the most successful attempt during the trial. However, the researchers did stress that there's a lot of data processing at play, so the success can't completely be put down to Star Trek fandom. Arvind, what can we learn here? Should we all be more unconventional with our prompts? If not Star Trek, then who should we be behaving like?
I guess the big question is, should every prompt be written in the words of a Star Trek captain, right? And I would say yes, because I'm a huge Trekkie fan.
And if so, do you want to be Kirk or do you want to be Spock? That's the question, isn't it?
Captain Kirk. I like all the Star Trek captains, and if I were to choose one, I would say Captain Picard. He's my favorite, though I love Spock too and Data. But taking this on a more serious note, before we go down the Star Trek rabbit hole, Stuart.
I think we're halfway down, but we can climb out and get serious.
Let's climb out. Prompt engineering is a well-known topic in the technology circles, and in fact, I've experienced this myself. Right, it's so interesting. I was brainstorming with ChatGPT on possible new ways of building out our innovation studio at our think tank. We were thinking of innovation and how we could build studios around it. And when I started researching this with ChatGPT, I said, "Can you take the personality of Steve Jobs and tell me what Steve Jobs would do?" And then after 2-3 minutes, I asked it, "Can you take the personality of a business leader and tell me what a business leader would do?" And so I was able to explore 15 different ways of looking at the same problem through the lens of these different leaders, which is what's going on here, right?
Right.
So the way you write and the way you prompt today is going to bring about the right results from AI. So I'm not surprised at it, though Star Trek Captain was interesting, but I think the broader theme here is that the way you write your prompts today matter, right? And if you write the right prompts, you'll get amazing results from AI.
Absolutely. And on that subject, what does the impact of diverse training data have on AI development? Can you kind of clue us into that?
That's a deep question for many reasons. When you say diversity in data, it's not just diversity of the types of data that AI sees, but in the sense, is it text, is it video, is it images, etc. But it's also the diversity in thoughts, in human opinions, right? Because if you're training an AI model on certain sets of data and it represents only one part of society's thinking, and if that AI model starts to dominate as the underlying layer of all of what we do, then it's going to have certain biases, and this is where bias comes in. So diversity of training data is highly, highly important for many reasons, Stuart, for many reasons.
Our second story today is all about CES 2024, one of the world's biggest tech events, which took place at the start of this year in Las Vegas. It was, by all accounts, dominated by artificial intelligence. The tech-on show included AI-powered pillows, pet doors, toilets, as well as a host of robot assistants designed to help with every daily domestic task you can think of. The main takeaway seems to be that the tech industry is pushing hard to make AI ubiquitous in our everyday lives. Arvind, is that the right track, or could it be too much too soon?
It's an interesting question. I'm going to flip that back to you and ask you a question around it. Do you like it when technology is sort of hidden and helping you live a better life? Or do you like it when technology is on your face everywhere?
I'm definitely one for the hidden world. If I feel like it's there, then it sort of becomes a difficult thing for me. I like it to be as invisible as possible.
And Stuart, you're not alone in that. It's amazing. We did a study a few years ago on this very question, and majority of consumers told us that they want technology in their life. So all these AI-based pillows, all of this is something that people want, but the most important thing is it's got to be in the background. It cannot be in the foreground, right? So when people develop these technologies, etc., please do consider that humans do not want technology staring at them in their face, right? Second part to the question you asked was, you need this sort of diversity in AI products because today we don't know where its full value is. So people are going to be coming out with multiple types of products before we figure out where the real value is, right? So not surprised that CES was filled with AI-based products.
So, Arvind, can you tell us a little bit more about what you're focusing on in today's interview with Professor Mausam?
Sure. Stuart, we focused a lot on large language models, right? In almost most of our episodes. Large language models are the foundation for today's artificial intelligence and the technology that's running it. But it's not the answer to everything. And so with Professor Mausam, I'm going to unpack what that means, right? Are LLMs the answer to everything, or are there other AI algorithms, other AI training methods, other AI technologies that we need to be looking into? So it's going to be an interesting unpack.
Well, here we go then with Arvind's deep dive interview with Professor Mausam. Our think tank focuses on researching emerging technologies that will shape your future. From generative AI to exoskeletons, we study the impact these technologies will have on business, humanity, and our planet. And through our podcast, newsletters, and social media content, we have a direct line to a truly global emerging technology community. So if you'd like to find out more about the impact these technologies will have on your business, then reach out to our team at lab45thinktank.com.
Hi folks, welcome to another episode of Unpacked. Is the current state of AI and are LLMs the answer to everything? Today I'm going to have a riveting conversation with a guest who's going to unpack for us the fact that LLMs aren't an answer to all AI-based problems. If you are trying to automate your factories, if you are trying to bring in predictive maintenance, if you want to do smarter planning, in all of these automation tasks, LLMs are one part of the answer and isn't the entire answer. And so the breakthrough that's happened in AI in the last couple of years in neural networks and language models alone isn't sufficient for us to get to this world we dream of, this world of AI based automation and what it's going to do for us. It's got the potential, but there is an X factor that's still missing. And how do we address that? I'm going to talk about that with our guest today. Our guest got his bachelor's from IIT Delhi and his PhD from University of Washington. He also taught at University of Washington. He founded the Yardi School of AI at IIT Delhi and is currently a professor of computer science at IIT Delhi. Um, Respected and reputed in the world of AI, He has been recognized by the AAA AI community. He's been recognized as one of the most influential researchers in the world of AI. And he has about 11,000 citations and 100 papers in the world of AI. Super happy to have Professor Mausam with us today. Professor Mausam, welcome to our podcast.
Thank you very much. Thanks, Arvind, and thanks, Wipro. It's really nice to be here and really excited to talk about this topic with you.
Yeah, we're excited too. Uh, our partnership with IIT Delhi and with you is something that's going to benefit the world. And so I'm excited to unpack some of these topics with you today. So, Professor Mawson, before we dive in a few words, can you tell us why are you passionate about artificial intelligence? Why is this meaningful for you? You've spent 20 years of your life in this world of AI. What drives your passion for it? Why is AI important to you?
When I was a graduate student, this is before the time AI became hot, overhyped, or hyped, whatever, and before all the recent advances in this field. The idea of making machines intelligent was just an amazing curiosity, right?
Uh,
Can we get, see, we always believe that humans are the most intelligent species on the planet, and this is what separates us from all the other animals, right? It's our brain. It's not like we are the giantest or whatever, because elephants are bigger. It's not that we are the fastest and so on and so forth. It's our brains that make us special, right? And so, what is so unique about the brain? How can the brain do what it does? What is the fundamental computational framework which can really enable our brain to specialize to so many tasks, to do so many tasks at such amazing level of abilities and skill? That core is the most exciting part of us, and therefore it became the most exciting part of computer science for me. Can we get that core into the machine? Can we somehow figure out how to make the machine intelligent? Also, if we could, the possible impact to the world would be huge. So while I was at that moment really not thinking so far ahead in the future as today we really think about AI being used everywhere. At that time, of course, I didn't really expect us to be here today, but nevertheless, if any little progress would have really helped the mankind in the long run. So those were the reasons I got excited then, and I continue to be excited today.
I love it. I got to say, that's one of the best answers. I ask all my guests this question, and I love that answer. And the reason I love it is because the perspective is so unique. What you're saying is, in the quest about learning about our own intelligence, which is what separates us from other beings, we are now transferring that to create an intelligence. So it's really a quest to understand who we are and how our brain works that drives us towards this other aspect of AI. That's such an interesting perspective. So, Professor Mossam, let's dive in, right? Um, Everybody today knows about large language models. People understand what it is. We've covered LLMs in depth in all of our different podcasts. But I think the perspective maybe that you're bringing to the table that's unique is that LLMs alone aren't the answer to everything. So let's unpack that a little bit, right? I'll start with a maybe a provocative question. Can you take an LLM today and just apply it in your factories? If you're in industrial automation, can you just apply it straight away for it to plan your supply chain? Or can you apply it to do predictive maintenance as it is? Is that the power of LLMs today? Or is there something more, right? Talk to us about it.
Great question, very important question, and also very important because with the advent of large language models, well, they have been around for 5 6 years, but in with the progress in the last year, suddenly people have started believing that LLMs are a panacea. They are a solution to
Yeah,
everything, and I think that's a
exactly.
myth that we need to really we need to break, and we need to think carefully about. So first, let's make sure we understand the word large language models. They are not large maintenance models or predictive maintenance models. They are not large doctors. They are not large. They are not large anything else but language. They were intended to learn language, right? Maybe make sentences, maybe summarize a larger body of text, maybe use some things from memory and answer some questions like, who's Barack Obama's wife, or things like that. Simple questions, or maybe slightly more complex, but they were not intended to be anything more than that. What happens sometimes is that when a model becomes strong, some emergent behavior starts to show. We use the word emergent behavior to denote that it's not that we intended for it to do that. It's that that thing emerged out of the intelligence of the being that
So
got created.
this is what we call in context learning, right? It's one of the emergent behaviors
In
that came out
context
of
learning
LLM.
was one of the emergent behaviors, indeed,
Yep.
indeed.
Yep.
And so what people did then is that when they trained these, let's say, GPT 3.5 and GPT 4 with humongous amounts of data and more, and humongous amounts of compute, they realized that not only has its language skills become extremely good, which is what it was intended in the first place for, its many other skills have been acquired by the model. And that is when they started asking it to write a poem, or they started asking it to I don't know, maybe solve reasoning tasks like answer math questions, or things like that, and more. And they started to be surprised. They started to be surprised at the level that, oh, we did not expect it to do that, but it did. It is more intelligent than we originally conceived it to be. And that led to a certain kind of an initial euphoria amongst the researchers, amongst the people working on it, to recognize that we didn't want it to be this, but it is more than what it is, right? But now, as the dust is settling a little bit, and as many of us, including myself, doing more and more experiments with the current abilities of these extremely large language models, we are clearly recognizing that they are not able to match up to the performance of smaller models trained for specific tasks. That's the first thing I would share. We have done numerous experiments in our group where, in older versions, where we had standalone models that were trained on standalone training data sets for a given task. Uh, that is when, if we train that model on that data set for that task, the performance is much better than GPT-4's performance. So you can say that's not surprising. GPT-4 isn't really trained for that kind of a task, and so on and so forth, right? But then these are such large models that training such large models every time for every new task is not going to be very easy. And moreover, only OpenAI can do it, because we don't even have the access to the parameters and so on and so forth. We also tried many other experiments where we said, okay, if we put GPT-4 and put in some more additional small processing on top of it, give it maybe more exemplars, do some in context learning, there are lots of tricks of the trade that are there at our disposal these days. Things called self consistency, self critique. There are many different ways to improve the quality of LLM output. And again, we were able to find that we couldn't really match up to the performance of the standalone trained models. That
Hmm.
is one thing I want to share. But you talked about predictive maintenance or automation in industry. So let's come back to that. To do a full supply chain management, the input is rarely language, and the problem is really huge. For example, you need to know who are all the various vendors which can supply a certain type of object. How many objects do you need of a certain type? What is the cost of buying it from a given vendor, etc., etc. There are lots of numerical parameters that require to be considered when doing this kind of an optimization or supply chain management. LLMs are just, they will be completely like a fish out of water in these sort of situations. They have no business coming into that place right now. For example, even if you ask an LLM to do like a simple reasoning task, like give it a puzzle which is bigger than something small, so there's just no way a large language model will be able to answer, because it's not intended for that.
So
Uh,
can I ask a quick question there, Professor Mausam? if you don't mind. We will come back to the predictive maintenance in a minute. How is it possible then that they're publishing? I read a paper recently from OpenAI that says that GPT-4 passed the bar exam, right, with 95th percentile. It's getting all these amazing scores in biology, and there's a lot of logic involved, right? You can't pass the bar exam if you don't have logic. You can't pass GMAT if you don't have logic. I went through the GMAT myself, and some of the things you're talking about, you had to rack your brain and really think through the logic of it. So, is it hacking its way through this without really understanding just because it knows language patterns? Or is it truly solving these problems at these tests?
This is a hard question for me to answer. It's an awesome question, by the way. It's like the right question to ask in this context. Um, Let me share with you one of my own experiments here, and then I'll come back to your answer. One of the most difficult exams in India, which are a cornerstone of intelligence, are the IIT JEE entrance exams. Many
Yes.
people, if they are not from India, may not realize, but there are hundreds of thousands of students take this exam for just a few thousand seats, and it's an extremely competitive exam which happens after the senior high school, and this is for college admission into the coveted IITs, right? And our a priori guess was that, look, because so many students study every year for these exams, therefore they always make more difficult and novel questions, unique questions. They put in the effort to make unique questions so that somebody has not memorized an answer to a related question in the past and just can sort of parrot it out in the exam. So these are hard questions. And our a priori guess was that LLMs will just crash and burn. To our surprise, and to support what you are just saying about their ability to do reasoning, um, they would not get into IIT. They would not pass it at a level that they can enter an IIT as a student. I'm saying, when I say they, I mean large language models. But their performance, and not just performance of every large language model. For example, even GPT-3, Chat GPT, Llama, they were all terrible. But the performance of GPT-4, and only GPT-4, after some of the bells and whistles that we added to it, actually ended up being quite creditable. It was in like 80 percentile level, which is incredibly amazing. And this paper is under review. So we were also surprised, right? So I would not say that Chat GPT or GPT-4 has no ability to do these. I am not going to say that. And I mean, the legal exam is a little bit easier exam because there's a lot of text based reasoning.
Yep.
There is more numerical based reasoning or more scientific reasoning. We did find the performances to go lower. However,
Got it.
a supply chain management is like a pure optimization problem with
It
too
is.
many
It's a
moving
mathematical
parts.
problem.
It's a
Yep.
pure mathematical problem with too many moving parts, which a human might even not be able to solve because there's just so many things going on, or it will take a long time. So, at least for that level of complexity of optimization and reasoning, the large language models are not going to be able to scale up, right? But their emergent behavior in reasoning is much better than what we all anticipated before they came, right? To answer your
Got
question.
it.
Coming back, however, to your original thing, think about predictive maintenance of various manufacturing devices that are in our building or in a factory. There is a lot of sensor reading that is coming in, right? Think about any kind of sensor, noise sensor, temperature sensor, humidity sensor, whatever it is. It is sending you numbers and a time series of numbers. And a time series data like that in a factory is just sensors after sensors after sensors and time series of numbers after numbers after numbers. This nature of data, again, a large language model has no business even interacting with it because it's a very unique, very specialized data, and large language models can only interact with words and communicate in sort of natural language and so on and so forth. They can think a little bit more than they could, but the communication is only through language, not natural language, not.
Transformer architecture, once it came out, it currently has solved this problem of understanding a sequence of words or a sentence? Or do you still feel there are gaps in it? And is there other nuances I'm missing to that?
I would say that's an oversimplification. Solved problem. So let's for example use a transformer architecture. Well, transformer by itself cannot do much. Let me just put it this way:
Mm.
it's a better architecture than, given a huge amount of data, it's a better architecture for a lot of tasks in language. But it still needed annotated training data. Then the large language models happened, and when large language models happened, some of them are able to, the very recent ones are able to make it appear as if they have solved some of these problems. And there is a lot, that I disagree with here, with regards to the ability or the hype of the ability that these large language models have. For example, you ask large language model a question about Barack Obama, it is very likely that it is going to give you a correct answer. But you ask a question about, a lesser known entity, let's say myself or yourself, there's a good chance that it is going to make up facts. The technical term that we are using these days is hallucinations, although that's not an ideal term here. But basically, it's making up information. It is making up facts. It is making up things that don't exist. And it is happening a lot of times. So when we start thinking about information systems, trust and making sure that the information that we send out is appropriate and accurate based on the information source that we have at our disposal is critically important. Another way of thinking about this is, let's say you are Wipro and you have your own proprietary data, and your own proprietary data, you need to put together an information system on top of it. Now, you may be very uncomfortable at the idea that I'm going to give all this to OpenAI so that they can train one large language model and all this information is in there. So when you have proprietary data set, then also you cannot easily use like a standard transformer architecture and just get the results that you're looking for. Again, transformer architecture is a piece of the puzzle, but it's not the full puzzle, solution to the puzzle. There are many such reasons why some of these problems that have become mainstream after ChatGPT showed up in our world. Um, it makes us believe that we have really solved those problems and we have made progress, but there's much more to be done. And a simple example is, can you ask large language model to can a large language model shut up when it doesn't know the answer? And
Mm.
absolutely the answer
That's
is
what,
no.
that's what I was wondering. If it doesn't know the answer, why doesn't it say I don't know? But it seems like it doesn't even know that what it's saying is incorrect,
That's right.
right?
It doesn't have the ability to introspect at a level where it can self-critique its own its own writing before writing it. Right. We did a lot of experiments on this, and we found that most of these neural models, including most transformer architectures, right, because all of these are now transformer architectures, they will all generally generate an answer, even though the answer is not supported by evidence, and they will.
Holy cow. You're saying even if you ground these models in a database, they're still going to give you some of these answers which are not factual.
Unless we work on those problems, yes.
My God.
How often when the question was unanswerable, was it able to stay quiet and say this is not a question I can answer, right? So those are the kinds of analyses you could do, and we found that when we did this analysis, original models, they will almost never say the question is unanswerable, even after grounding. And when we trained our systems specifically for this task, they did better. But then there was a gap, right? So their original performance on the answerable questions was much better. And after training on this task, their performance sort of went down overall, even though their unanswerability performance improved.
My God. Professor Mausam, then what I'm understanding is that um, if I'm a business leader today, that puts me in a pickle, right? Because do I deploy these models or do I don't? And where do I deploy them in a safe manner where they won't provide these answers that are incorrect? So has your team sort of thought about that? Like where should these be deployed? Where should they not be deployed?
Yeah, and the answer to that question is kind of case by case, right? Because the deployment is not just governed uh, by an AI researcher, it's often governed by the domain expert who thinks about where AI is useful. And there are questions outside of AI that also need to be thought about here, because sometimes, for example, in a country like India, um, the choices and the answers for where to use AI will be different than in a country like US or a country like Japan. So that aside, technically also, one has to think about where mistakes are okay. For example, Google, right? So when you ask Google a question, or when it sends you some websites to look at, if it makes a mistake, it's not a big deal. If you're a Facebook and it is recommending, your Instagram and it is recommending some videos to you, and it recommends a video which is not perfectly suited to your interest, then I think it's okay, right? On the other hand, when a machine is reading an X-ray or a CT scan, and it starts to say, "Oh, you have cancer," or "You don't have cancer," and it starts to make many more mistakes than a typical doctor, or even if it is making fewer mistakes or whatever it is, the point is, by not having an expert in the loop, one can actually really go down a path which is undesirable. There are other settings. For example, it's an imperfect AI system, but it's in a disaster recovery area. We could not have sent our people. The peacekeeping forces will take time. It's risky. If AI can contribute some, it's great, right? And you have to think about guardrails. You have to think about what it should be able to say, what it should not be able to say, what safety mechanisms it needs to put in place. And OpenAI has also thought a little bit about it. So, for example, you must have heard that GPT-4 initially was a more intelligent system, but in order to do more alignment with human values, they trained the model. After training it fully, they trained the model further to make sure that some of these known situations don't happen. In the process of this alignment training, they actually dumbed down the model a little bit. That said, there is still much, much more to be done. And a lot of my research currently is about, well, large language model can give us something. It will give us some value because it's trained on such large data sets. But can we put in an interesting post processing system with the large language model in the loop, such that our overall task performance is much better while more guardrails being in place?
Hey, Professor Mausam, tell us about the symbolic part. That's something I'm hearing new.
So, computer science
What?
traditionally uh, focused more on discrete objects. If you think about arrays or stacks, right? This is what we learn in our data structures, leading to graphs, right? Graph algorithms, Dijkstra's algorithm, sure, minimum spanning tree algorithms. These are all algorithms that are manipulating nodes and edges, which are considered symbolic objects. Alternatively, AI had been developed with a logic as one of the tenets. So a lot of theorem proving systems, a lot of systems which did what is called bounded model checking, would convert problems into a satisfiability problem and will solve those problems. So a lot of reasoning used to happen through the modus operandi of logic. We can combine all of these algorithms and representations into what we call symbolic AI. And it is my belief that neural does much better on perception tasks, but symbolic does much better on reasoning tasks. And so even today, when we ask large language models to do planning, it doesn't do as well than it does many of the more communication oriented tasks, which require more perception. It can also do more reasoning than before. So it's the split is no longer very fixed or explicit that neural models will not be able to do good reasoning. That's no longer true, but it is still true that symbolic architectures have better, and they are more scalable for large reasoning problems.
Can I then interpret also that in scenarios such as utilities, right, electrical utilities, where you have faults in lines or electrical parameters, you have all these large matrices of voltages, currents, etc. So again, an LLM is not going to be the right choice for you to try to predict where the next fault is going to occur, right? Same as it's all mathematical based reasoning. So this is not the right tool, definitely, for most mathematical reasoning based data sets, numerical data sets, large data sets. I think that's important for our audience to sort of let it sink in a little bit as you continue. Go ahead.
Right. So I think I think I'm close to completing the story. So the point I was trying to make is that there is huge progress in large language models. It can do things that we couldn't have conceived, like IIT JEE questions, right? But it is not an answer to everything, and depending upon the nature of the problem, it may still have a role to play. For example, a large language model has a innate ability to write code, and software has innate ability to work with numbers because it has primitives like plus, minus, multiplication. You can piece together instructions to do something more complex. So what we have found in our work is that if you ask it to do reasoning, it doesn't do a good job. But if you ask it to write code to do reasoning, it does better job.
Oh, that's amazing.
If you
Okay.
ask it to write code not to do reasoning, but to invoke a standalone reasoner, which is developed for the last 50, 60 years in our world, like an integer linear program or a satisfiability solver or some of the traditional reasoners, like the symbolic reasoners that our field and operations research and AI and computer science have so painstakingly developed, we should not lose sight of them. But a large language model could have the ability to give the right input to those solvers and take their solution and convert it into the format that we were looking for. So they would become like amazing rappers, or they would become like amazing communicators to other standalone tools that exist in our world. But they are not
Amazing.
independent solution for all these problems.
Got it. No, that's amazing. But even the fact that they can help us write code to solve some of these problems, that's pretty phenomenal, right? That's pretty phenomenal. So, in the beginning of our conversation, you did say that you actually have done tests where small models in some tasks are performing better than LLMs. Can you give us some examples of what those small models were and how did they perform better than LLMs?
Yeah, sure. So we are comparing a model trained on some data on the specific task, and
Yes.
a large language model which is not trained for this task, which may have in context learning, but it's a generic model, right? So it's an arguable question whether this is a fair comparison. But just to answer your question, my one of my core areas of research is NLP, and even in their information systems, where we try to answer questions on top of knowledge bases, or we try to do dialogue between a user and an agent, sometimes to maybe do recommendations for restaurants, or sometimes to do recommendations of whatever the query has come in. So there are interactions, right? And also in all such scenarios, you have to interpret the intent, interpret the language that comes in. You also have to do some reasoning. You also have to go and look for knowledge in the knowledge base and extract the right kind of knowledge and use that knowledge to piece your answer and give the answer out. And we found that for both knowledge based question answering and task oriented dialogue systems, which are the two case studies that we are currently working on, in both those cases, the state of the art model before GPT-4 came in, which is trained on specific data, which is a much smaller model than GPT-4, most likely, because GPT-4 nobody knows, but presumably, and is doing much better than an in-context learning, and even some workflow on top of in-context learning to get the best answer. We are trying really hard to get close to the pre-trained, I mean, to the task-specific models. Uh, I'm hoping maybe someday we will be able to. We are also trying to see where large language models may have an edge. For example, they have an edge in generating language, and not surprisingly, right? So, if the standalone model can figure out what information to convey, and we give that information to large language model to piece together in an utterance and convey it to the user, then large language models really do well. So I think that would be one of the many ways in which sort of standalone models and a large language model could interact in the future, because LLMs will have certain strength, they will have more knowledge of language, they will have better ability to understand language, they will have better ability to generate language, but then task specific reasoning, task specific processing might be done by some other things.
Got it. So, Professor Mausam, then for all of these other applications today, where we're talking about predictive maintenance or utilities or smart factory automation, um, there has been research on how to use AI to solve these problems. There has been research ongoing for a while, right? On how do you get AI to understand numerical data and do math-based reasoning. Those architectures, those methods, are they still relevant? And are we going to see a new set of methods come up based on what we have learned from LLMs? Or do you see the old methods and LLMs being married together, or a whole new set of methods coming out? Can you tell us about what you are seeing as the future of this?
I hope all of these, right? So, first of all,
Correct.
absolutely, the answer to your first question, are those traditional methods relevant? I want to believe they are. And in just many experiments over the last several years, we have found that uh, the whole AI need not be neural. Not everything needs to be done by neural models. And this is, by the way, in my opinion, in contrast with how Yoshua Bengio, the legendary Yoshua Bengio, thinks about it. He feels that symbolic methods have a certain advantage, where I agree with him. However, he feels that the neural models must inherit those advantages. He wants to build better neural models that inherit those advantages, which is another way of thinking about this world. My way of thinking about this world is, look, we have done 70 years of computer science. We have done 70 years of AI at least, and maybe more years of computer science. We have developed many algorithms. We have developed many representations. They are not all equally good for nothing. They have a lot of value. You have to think about what the value they bring in, where they should be used, and how they interact with the neural model. But having them interact with the neural model is critical, because then you get some of those benefits of symbolic models for free and also neural models for free. And then you have to think about the piping a little bit better. So this is what is called neurosymbolic AI. It has been very popular in the research community in the last 5 6 years. I believe even in AAA 2021, a couple of years back, there was a full track on neurosymbolic AI, and a lot of new exciting methods have been developed. More will be developed. Now, with the advent of large language models, I think the same kind of analysis and same kind of at least model building is going to happen. So, would for many of these problems, will we see completely new architectures? I don't know. That's a harder question to answer. Would we see architectures where the neural models, the large language models, for example, and the more sort of task specific models, they will interact with each other? I think absolutely yes. I think that will be the first step forward. People will try to solve those problems with LLMs. They will reach somewhere. They will not reach far enough. They will be dissatisfied. Then they will say, okay, what does LLM give me that new task specific models did not? What do task specific models give me that LLMs cannot? How do I combine the two? How can I get the best of both worlds? I think this is how the field evolves. You have two, three different ways of thinking, and you realize that God is not just that, or just that, or just that. God is in everything, or whatever. You can take your analogy. The truth is everywhere, and it's in combining all of them that we get to the right answer. At least this is how I think about the world.
No, thank you for sharing that perspective. I think a lot of the points of view you shared today, I do think people need to understand this, and enterprise leaders need to pay attention to this. So, neurosymbolic AI is something that people should be looking at, and also the advances in LLMs and their work with other architectures. So, Professor Mausam, a last question for you. What is the current book you're reading on AI, or a current paper you're reading on AI that's super interesting that we should know about?
All right. So let me think about this. Um, I have recently acquired this book by Toby Walsh. Toby Walsh is a very famous researcher from Australia, and he has been particularly vocal about the ethical issues of AI, the topic that we didn't get to cover today. And he has been thinking about a world maybe 30, 40 years far, and thinking about what would be the challenges there. So his book, it's right in front of me. Let me see. Yes, it's called 2062. This is the book. No, I was not intending to publicize the book, but advertise the book.
No, but it's cool. I still want to hear about it.
And so now I would not say that I agree with the full picture that Toby paints, but it's a good idea to always, read people who think differently than you, to get a sense of, what are the gotchas, what are the challenges that can arise, and things like that. Even today, when I think about 1 year ago, I was just not scared about job loss. But after the advent of GPT-4, I'm starting to get a little bit scared, in all honesty, right? I have been an AI champion for the last 20 years of my life, and I have been a vehement supporter that humans have been incredibly creative all through their lives. I mean, all through the generations, and as new technology comes in, humans will figure out a way to work with it and really add value on top of it. But as these models are starting to get surprisingly effective for some specific tasks, right? It begs the question, if more and more of that happens, then what is the world order going to look like? Whether we will have some really privileged people and many others trying to fend for themselves in the world of AI. I hope that doesn't happen, and I'm hoping that the countries, the regulations, the ethics, the ethical use, thinking about when to use, when not to use, and collectively as mankind, we would be able to really figure out a ways for AI and humans to coexist. But this book tries to take it to the other extreme in some cases, in some chapters, and sort of gives you a sense of what could be a bad outcome of how the cards would get played of AI. So it's good to read that.
Yeah, 2062. I'll definitely buy a copy. I'm always interested in new books. And I think, Professor Mausam, this is a great way for us to wrap up our podcast today because what you're saying is correct, right? And I always believe that we have the ability to shape that future to what we want it to be, hopefully, to some degree. Not everything is in our control. The fact that AI became intelligent or started showing this in context learning, it's not something anybody could have predicted. It happened, right? And we are learning how to work with that. And so we don't know some of the things that will happen. But I do think that if we have the intention of of um, driving value for humanity through our actions, then that will really help s- set the guardrails. If every business leader is thinking of not just how do I make money with this new technology, but really what are the consequences and how do I deploy it in a responsible manner, then I think some of these things will, like the guardrails will form on its own, right? Is what I believe, but we will see where that future, how it'll go. I do encourage everybody to look at 2062 that Professor Mawson's reading. It seems like there's a different perspective that we should all be aware of. And Professor Mawson, thank you so much. This has been super educational for us. And we will do another episode with you, maybe on deep dive on the ethics of AI. I think it's worth it to do that. So I look forward to having you again in our podcast.
Thank you, Arvind. It was really fun chatting with you, really fun talking about my research, and that is the way I think about AI and its development today. So really enjoyed. Hope the audience also appreciates it. I'd love any feedback.
Sure. And yeah, I encourage people to reach out to Professor Mawson. In our podcast, we will leave links to him and his research. So do reach out to him if you want to talk more about NLPs, the future of AI. I know he's got a lot to say in this particular area and his research. And look up the Yardi School of AI at IIT Delhi, which he's founded, and do connect with him. Thank you, Professor Mawson.
Arvind, great interview as always. Can you talk us through some of the things that you thought were most important there?
Yeah, Stuart, I thought Professor Mawsam brought in a completely new perspective to a lot of what we've been talking about, right? In most of the episodes, we've been talking about large language models and LLMs and how they solve so many problems. And he brought up a completely new perspective, wherein I think the key takeaway from his talk is that for business leaders, large language models are not the answer to all your problems, and they're not going to solve all use cases. And I'm going to take one specific use case to illustrate what Professor Mausam said. If you take the use cases of predictive maintenance or factory automation, those use cases require heavy mathematical computation. And so in those particular use cases, LLMs may not fare as well. To give a concrete example, I think he quoted the fact that today an LLM can't solve a 25 by 25 math Sudoku problem, right? They're not built to do that. They are built to be trained on language and reason based on language and based on language inputs. Now, it's not going to be the case in the future, but today that's where they are. So the message from him is there's another type of artificial intelligence, which is symbolic AI. And so you need a combination of both LLMs and symbolic AI in order to solve some of these larger use cases or problems like predictive maintenance and factory automation, right? So you got to keep that in mind, especially in these early stages where AI is being deployed everywhere. Ask these questions on, is the problem quantitative or is the problem qualitative? Summarization is a qualitative problem. Predictive maintenance is a quantitative problem. And so LLMs may not be the answer to that, right? So it's important for business leaders to ask those questions.
Fascinating as ever. Great brain food. Thank you so much for all your insights today, Arvind. It's been great as usual.
Awesome, Stuart. Thank you.
If you like our podcast, please like, subscribe, or tell a friend. I'm Stuart Black, and see you next time